The action potential. So when a neuron is stimulated, sodium ion channels open, and if the stimulus is big enough, it triggers a change in the potential difference, and the cell membrane becomes depolarized. So here are the steps of the action potential. You've got stimulus, depolarization, repolarization, hyperpolarization, and resting potential. So I just made up a mnemonic for this to remember it. So silly deers run hyperactively round. Stimulus, depolarization, repolarization, hyperpolarization, and resting potential. So a stimulus is when it excites the neuron cell membrane. So sodium ion channels open, and the membrane becomes more permeable to sodium. So sodium ions diffuse into the neuron down the sodium ion electrochemical gradient, making inside of the neuron less negative. So that's here where the stimulus starts to make the inside of the neuron less negative because the sodium channels open. Depolarization happens if the potential difference reaches a threshold value, and it's approximately 55 millivolts, but you'll have to read off the graph in the exam question. At this point, after the threshold is reached, all the sodium channels open. Lots and lots of sodium channels open, so loads and loads of sodium ions diffuse into the neuron, eventually making it become positive. So that's when it's known as depolarized, when it becomes positive. At the top of the action potential, which is around 30 millivolts, but again you'd have to read off the graph in the exam question, the sodium channels close, but the potassium channels open. And therefore the membrane becomes more permeable to potassium. So potassium ions diffuse out of the neuron down the concentration gradient. And this starts to get the resting potential back to normal, because if positive potassium is moving out of the neuron, it's going to become more negative inside in comparison to the outside. Then there's a stage called hyperpolarization, and that is where the potassium channels are quite slow to close. So there's a slight overshoot where too many potassium ions diffuse out of the neuron, and the potential difference becomes more negative than resting potential. So it becomes more negative than minus 70 millivolts. And then after that slight overshoot, the resting potential kicks back in, and the ion channels are reset, and the sodium potassium pump returns the membrane back to its resting potential by pumping 3 sodium ions out for every 2 potassium in, and then the potassium diffuses out of the open potassium channels. And this maintains the resting potential until the membrane is excited by another stimulus. It's probably important to point out that during the repolarization and the hyperpolarization period, that is known as the refractory period. So at the first bit here, that is the resting potential, but at the bottom of this resting potential, a stimulus might occur which opens some of the sodium channels, which makes it a bit less negative. And if that reaches a threshold value, usually around minus 55 millivolts, then all of the sodium channels open and lots of sodium come in, and that can make it positive. And at that point, that is known as depolarized, when it becomes positive. At the top of the action potential, which is around plus 35 millivolts, the sodium channels close but the potassium channels open, meaning potassium can diffuse out of the axon, and therefore it becomes negative again. So it becomes repolarized inside of the axon. And then the potassium channels are quite slow to close, and therefore the membrane, the inside of the axon, can become more negative than resting, and that is known as hyperpolarisation. And then the sodium potassium pump kicks back in and the resting potential is restored. So you might see permeability graphs. So when the membrane is depolarised, that's when the sodium channels open. So that's when your sodium ions the membrane will be more permeable to sodium ions. At the top of the action potential, when the sodium ions shut, the sodium ion channels shut and the potassium ion channels open, the sodium permeability decreases, but the potassium permeability increases. And that's why when it becomes repolarised. Now it's important to note that the ones that open when it reaches threshold at about minus 35 millivolts, they are known as voltage gated sodium channels. So the gates only open when they reach a certain voltage.